Welcome. In this video, we're going to look at one of the questions under Newton's second law of motion. And the question says, the figure below shows three blocks of mass. M1 is equal to 1 kg, M2 is equal to 1.5, and M3 is equal to 2.0 kg. So this is the figure, and mass 1, mass 2, mass 3. And these masses are being given the same push by this force, and they are on the same surface. So the question says, now this is okay. The question now it reads: how large a force F is needed to give the blocks an acceleration of 3 meters per second squared if the coefficient of kinetic friction between the blocks and the bench is 0.2. So we are told now to find, or rather, we are required to find the magnitude of this force that must push these masses to the right, yes, in this direction, by, in fact, by this acceleration, giving them this acceleration. So from here, what we're going to do is the same coefficient of kinetic friction. So what we're going to do is we are going to come up with the common mass. We are going to come up with a common mass. So M is equal to M1 plus M2 plus M3. So let's call this as equation number 1. Now, for this, we can come up with now a free body diagram. So we have this one, which is this is the M, and we have the force that is giving it this push, and we have the friction force in this direction. So from here, we know that again, there is a normal force that is acting on the mass. So we have the normal force here, and at the same time, we have the weight, which is the mg, which is the mg. So this is the free body diagram. This is the free body diagram. So we have this. So from this mass, we have this. Now we know that from Newton's second law of motion, the summation of forces must give us ma. So in this vein, we are going to say the summation of forces in y is equal to ma. But since we do not have the motion here, it is not, we do not have, the blocks are not moving in this direction. So the A here is 0. So the summation of forces in y is going to give us a 0. So we have the M there, which is the normal force, minus mg must give us a 0. So that mgn is equal to mg. So this one, we can call it equation 2. And from here, we know that the summation of forces in x must give us ma. And since we have an acceleration of 3 meters per second squared in this direction, we say the F, which is this one, minus the friction force. This must give us ma. So let us call this equation number 3. But from this, we also know that the coefficient of kinetic friction, or the coefficient of friction, so the coefficient of friction, which is mu, is given by the friction force over the normal force. So if we make friction force the subject of the formula here, we are going to find that the friction force is going to be mu n, which is the normal force. So let's call this one, okay, let's just call this asterisk 1. So this one, this is the friction force, which is given by this. Now from equation number 3, which is this one, we know that F minus the friction force must give us ma. So if we replace Fr by this, we're going to have F minus mu n, which is the normal force, is equal to ma. And from here, we also know that the normal force is equal to the weight, which is the mg, as from equation number 2. So equation number 2 into this equation. So let us call this equation number 4. So equation number 2 into equation number 4, we are going to have F minus mu mg is equal to ma. So from there, F minus mu mg is equal to ma. But know that m is equal to this, is equal to m1 plus m2 plus m3. This is the common mass. So we can just plug in this. So F minus New equation 4, we are going to have M1, M2, M3, G is equal to M1 plus M2 plus M3 multiplied by A. Now, so from here, since we want to find the value of F, so this is going to cross the equal sign so that it becomes positive. So we are going to have M1 plus M2 plus M3 A plus the mu, which is the coefficient of kinetic friction, plus M1, M2, M3 times G. So here, what we need to do is just need to plug in the values now. So the M1 is 1 kg plus M2 1.5 kg plus M3, which is 2 kg, times the acceleration, which is 3 meters per second squared, plus the coefficient of kinetic friction is 0.2, then M1 1 plus 2, these are kgs, times 9.8. So here what we're going to have is, so 1 plus 1.5 plus 2, we're going to have 4.5. 4.5 times 3 plus 0.2 times, so this is the same, 4.5 times 9.8. So punching this on a calculator, we are going to get 22.3 newtons. And this is the answer. So this is the value of F that must give the blocks 3 meters per second squared. Thank you so much.